Today's lesson is on a topic called solids of revolution. This is where we essentially take a three-dimensional solid in two-dimensional form and revolve it around an axis of rotation. This is very difficult to see on paper, so what I recommend you do, this YouTube link right here I posted in the playlist. So definitely give that a check and watch it so you can understand what this idea of solids of revolution looks like in 3 dimensions as it rotates through. So on our notes here, what we have is, in this example A, on the top left, you can see the laser pointer inside the rectangle. All right, what shape would this make if we revolved it around this? Essentially, this will be we're going circular around this particular axis of rotation, and what is created is going to be a cylinder. Right, so if you think about it, this part up here in the top right will be a circular motion. It'll make a circular path, and the result will be a cylinder. In this particular shape, this distance right here that's perpendicular to the axis is the radius. This distance up here at the top of the rectangle, if you can see the laser pointer, the top of the rectangle is the height of the cylinder. In example B, if we were to rotate this would create a cone. This example probably makes more sense to you because you can see how this would spin and create a cone. So again, the length perpendicular to the axis is the radius, right? So here's our axis. This is the length perpendicular. This will be our radius. This distance that touches or is parallel to the axis is the height of the particular solid. So in this case, we would have a cone. All right, in the bottom left, right, this distance right here, perpendicular, we don't have a line, but it's perpendicular to the axis, is going to be the radius in this case. So we are going to end up rotating this and creating a sphere. All right, in part D, we'll talk about this, but we're not really responsible for it for any assessment. What makes this different is there's a space involved. And so when we rotate this thing around the axis, a hollowed out portion is created in the solid. And this is what we would call a hollow truncated cone. Essentially, it's not quite a cone because the top is cut off and there's a hollow section. So this is one variation that we'll see, but you're not responsible for this particular shape. This is what a hollow truncated cone will look like minus the section in the center. So if you imagine a cylinder cut out of this, that's what would be the result of this triangle rotating in space. All right, so what happens, say for example A, if we were not touching the axis? So if this were not touching the axis, what would happen is we would get a cylinder with the cylinder removed. Okay, so that space created between the axis and the shape will create a hollowed space. All right, again, just to summarize, what relationship does the radius and the axis line have? They're perpendicular to each other. That's important. You have to be able to identify this. All right, what relationship do the height and the axis line have? They are touching / parallel. It depends. And example 1, A, B, and C, they're touching, and example D is parallel. It's not touching, but it would actually be that. All right, so here's a couple more examples to look at. All right, so in this case here, we have this triangular shape listed. If you can see the laser pointer in the center of the triangle, right? And we have our y-axis vertically and our x-axis horizontally. So if we were to rotate this, in example A, around the y-axis, what solid would it create? So the y-axis is vertical. So what happens is, if we took this triangle and rotated it forward and around this way, what would it create? And that would create a cone. So we need to find the volume. So remember, the axis of rotation perpendicular to it is the radius. So in this case, our radius is 1, 2, 3, 4, 5, and 6. And the height is 4. So we would plug in our formula and get a total volume of 150.8 or 48 pi. And in either case, either answer will be accepted in pi or decimal form. Even though the directions say in terms of pi, decimal is still okay in class. All right, for this one here, the line x equals -1. Well, the line x equals -1 would be on the very left of the graph. Okay, and if we have a space created between the shape and our axis, what is created? If you remember from the previous slide, it's a hollowed out space. So in this case, this would be a hollow truncated cone. And for this particular example, we are not going to do the volume of, but just to talk about how this line here creates a hollow space. All right, so for this next one here, we have our shape in the top right corner. All right, so if we want to rotate this around the y-axis, that's going to be the vertical axis, and that will be the height. The perpendicular line to that axis will be the radius. So in this case, the radius will be 4, the height will be 2. And the solid shape would be a cylinder. So now, because we have been practicing cylinder volumes, you should be able to calculate the volume of a cylinder, which should give you 32 pi. All right, for example B, we're going to rotate it around the x-axis. So essentially, we're going to take this shape and rotate it downwards. So the solid that will be created is going to be a cylinder. Now, because we're going down this way, right, the axis we're rotating, right, the height is going to be 4 and the radius will be 2, because the radius is perpendicular to the axis of rotation and the height is parallel to the axis of rotation. So we plug the values in to our formula for cylinder, we would get an answer of 16 pi. All right, for example B, down here, this other B, this should be example C, but it's example B. So this third example on the bottom left here. All right, the line y equals 2 is actually the top of the shape, right? And so what we're going to do now is rotate this thing upwards around the top portion. And so we're going to have a cylinder. But now when we rotate it up, what is the radius? Well, the radius will be perpendicular to that side. So the radius will be 2 and the height will be 4 this way. And so if we look over here, just to redraw it on the left side, this is our axis of rotation. Okay, and we plug in our values and we get a value of 16 pi for volume. All right, for the line x equals 4, that's going to be the line on the right side. So we can see that over here. It's the line on the right, and we're going to rotate this thing to the right in circular motion to the right. What's going to be created is a cylinder. Now, when we rotate this to the right, 4 is going to be our radius and 2 will be our height. So we plug these into our formula and we get a volume of 32 pi. All right, these examples down here, you do not have to do. These are going to be more examples of those hollowed out spaces that you are not going to be assessed on. All right, here's an example of the triangle. And so we know from prior slides, the triangle is going to give us a solid of a cone. So we're going to look at a couple of these examples here. So in example A, if we're going to rotate it around the y-axis, right, that's the vertical axis. So what is perpendicular to that? That's going to be down here, and that distance is the radius of the cone. The height of the cone, sorry, we're going around the y-axis, which is going to take this thing this way. So perpendicular to it would be down here. Okay, and we get a volume of 12 pi. All right, for part B, we're going to revolve it around the x-axis. So in this case, we're going to revolve it downwards. Okay, we're going to have a cone and a volume of 16 pi. All right, these examples here you are not responsible for.